Hello students, welcome back to my YouTube channel. In this video, I am going to discuss motion in a plane topic vectors for NEET and JEE. If a body is moving in a straight line, it will have two possible directions. It can move in the forward direction or it can move in the backward direction. So we are using the positive and negative sign for representing the direction of motion. But if a body is in a plane, it have more than two possible directions. So the positive and negative sign is not enough for representing the direction. So we are introduced a concept that is scalar and vector. So the physical quantities are classified into two types. One is scalar quantities and other is vector quantities. Scalar quantities have only magnitude. That means to understand the entire characteristic, magnitude is enough. Example, mass, time, temperature, these are all scalar quantities. Vector quantities have both magnitude and direction. Because to understand the entire characteristic of this vector quantities, both magnitude and direction is necessary. Example, force, displacement, velocity, that are all we can consider. Okay. Then next we will see how we can represent a vector. Representation of vector. Representation of a vector. A vector can be represented by a line with an arrow. Okay. A vector means like this vector. Okay. So this length of the line gives the magnitude of the vector. That we will say they will write like this modulus of A. Or we can write like this A. The arrow cut gives the direction. Okay. This. And another thing is unit vector. What is mean by unit vector? Unit vector have magnitude unity. Unit vector. How magnitude unity. If the unit vector of a vector gives the direction of that vector, if A is a vector, how you can find out the unit vector? Its unit vector we can write like this A cap, and we can find out by A vector divided by its modulus. Okay, so this A vector I can write like this, the modulus of A vector into its unit vector. Okay, then this is about the unit vector. Next we will see the addition and the subtraction of vectors. So the scalar quantities we can add like normal mathematical operation, but the vector quantities have both magnitude and direction. So it is not possible to add like scalars. So we have to add the vector quantities by using vector algebraic rules. So there are two rules are there for the addition of vectors. That is, one rule is triangular law of vector addition. Triangular law of vector addition is that two vectors can be represented, the sides of a triangle taken in the same order, then the resultant is the third side of the triangle taken in the opposite order. That means if this is a B vector and this is a vector, these two vectors we can consider the sides of a triangle, but we have to draw in the same order. This is the tail of a vector, this is the head of a vector. So I am going to place this B vector tail to the A vector head. So like this. Now you see A vector is from tail to head, B vector also tail to head. So these two are in the same order, then the resultant is in the opposite order. That means like this we can do, like this. Okay. So this resultant is the addition of A and B. Okay. What about the magnitude? Magnitude is equal to square root of A square plus B square plus 2AB cos theta, where theta is the angle between two vectors. Okay. Then if beta is the angle made by the resultant to the horizontal, then tan beta tan beta is equal to b sin theta divided by a plus b cos theta. Okay, this formula you can apply for finding the direction. Okay, this is about the triangular law of vector addition, and another law, that is the second law, is parallelogram law of vector addition. Okay, we will see that parallelogram law of vector addition. Parallelogram law. The parallelogram law says that two vectors can be considered the adjacent side of a parallelogram drawn from a common point. Then the resultant is a diagonal of the parallelogram passing through the common point. That means you look at this is the b vector and this is the a vector. These two vectors are making an angle theta. We can consider these two vectors are the sides of a parallelogram drawn from a common point. This is a common point. So I am going to consider the sides of the parallelogram. Parallelograms, opposite sides are equal and parallel. So this side I can consider A, and if I draw another side, this is to be B. Then the diagonal is this. This is the diagonal, that R is equal to A vector plus B vector. Okay, what is the resultant magnitude? That is equal to square root of A square plus B square plus 2AB cos theta, where theta is angle between A vector and B vector. If the resultant is making an angle beta with horizontal, then tan beta is equal to B sin theta divided by A plus B cos theta. Okay, this is the direction of the resultant. Okay, so if the vectors we can add only two, we can use this triangular law or parallelogram law. But if we need to add more than two vectors, we can use another law, that is Polygon Law of vector addition. That is the Polygon law. The Polygon law is number of vectors can be considered the sides of a polygon taken in the same order. Then the resultant is the closing side of the polygon taken in the opposite order. That means you look at this. This is the A vector and this is a B vector, and another, this is a C vector and this is a D vector. I need to find out A vector plus B vector plus C vector plus D vector. This is the resultant. Based on the Polygon law of vector addition, these four vectors we can consider the sides of a polygon taken in the same order. So this is a vector, this is from tail to head. Then I am going to place the B vector like this. Okay, you see, the same order. Then I am going to place the C vector like this. Okay, that is also tail to head. Okay, then I am going to place the D vector like this. Okay, then the resultant is the closing side. This is the closing side. This we have to take in the opposite order, that is like this. This is the result. This resultant is A plus B plus C plus D. Okay, this is the Polygon law of vector addition. Okay, now we will see subtraction vectors. Now we will see subtraction vectors. Okay, two vectors. This is the B vector and this is the A vector. So the resultant is A minus B. This I can write like this: A vector plus minus B vector. What is minus B? Minus B is the negative vector. Okay, which have the same magnitude of B vector, but it is in the opposite direction. Okay, so now you see this. The subtraction of two vector is the addition of a vector and the addition of another vector, negative vector. Okay, then you can use the triangular law or parallelogram law for adding two vectors. Okay, if you apply the triangular law, how you can apply it? Based on the triangular law, this is A vector and B vector you have to place in the same order. So like this. So negative vector means in the negative vector is in opposite direction but the same line. This is a minus b vector. Then the closing side is a resultant. This R is a resultant, that is A minus B. Okay, clear? This is the way we can apply the triangular law. Then I will show you how we can apply the parallelogram law. Okay, if this is a vector and this is a B vector, if the angle between them is beta. Okay, then what about my negative vector? Negative vector is same magnitude but opposite direction. So like this you can draw. This is a minus B vector. Now we can form a parallelogram like this. Like this. This is A vector. So this diagonal of the parallelogram is the resultant. That R is equal to A vector minus B vector. Then the resultant R is equal to, that is the magnitude of the resultant R is equal to A square plus B square minus 2AB cos theta. Okay, this is the alpha angle. Alpha is the angle made by the horizontal. So this is A vector. So tan alpha is equal to B sin theta divided by A minus B cos theta. B sin theta divided by A minus B cos theta. Okay, this is the formula for finding the direction of the resultant. Okay, this is about the basics of vectors. Now we will see the problem. First, type 1 problem. 6 vectors A through F have the magnitude and direction indicated in the figure. Which of the following statement is true? Okay, they are given how many vectors? A, B, C, D, E, F vectors are given. Based on the vector addition, they are given the so many statement. Which statement is true? Okay, so look at the first statement. What is the first statement? That is B vector plus C vector is equal to F vector. So based on the vector addition, we will check. What is the direction of the B vector? B vector is like this. Okay, what about the C vector? C vector is like this. Okay, this is a B vector and this is a C vector. So what about the resultant? Based on the triangular law, this is the resultant. Okay, so but this R is not equal to the F direction. So B plus C is not equal to F. Okay, then next B statement. What is the B statement? D. What is the D vector? D vector is in this direction. Okay, D vector is in this direction. And what about the C vector? C vector is in this direction. So I am going to apply parallelogram law. This and this we can play. So this is the resultant. Okay, then this R is not equal to the F direction. F direction is like this, but R direction is like this. So we can write D vector plus C vector is not equal to F vector. Okay, then look at the C vector. Look at the C option. There, the D vector is in this direction. What about the E vector direction? This is the E vector. Okay, then based on the triangular law, I can say that this is the resultant. This resultant has the same direction of F. So I can say that D vector plus E vector is equal to F vector. Okay, so D is the correct option. Okay, we will check the D also. C is the correct option. We will check D also. That is B vector. What is in the direction of B vector? B vector is like this and E vector is like this. This is the B vector and E vector. E vector is in this direction. This is the E vector. So the resultant based on the triangular law, this is the resultant. Okay. So here you look at the resultant and F are not in the same direction. So we can write it as B vector plus E vector not equal to F vector. Okay. This is about the type 1 problem. Now I am going to explain another type of problem. Okay. The problem is like this. If two forces have same magnitude and the resultant also the same magnitude of force. Then what about the angle between them? That means two vectors, the vector A and the vector B. The magnitude of the vector A is equal to F, and the other vector magnitude is also F. Then the resultant between these two vectors, vector A plus vector B, is equal to the resultant. The magnitude of the resultant is also F. Then what about the angle between them? Okay. So based on the vector addition rule, the magnitude of the resultant is equal to square root of A square plus B square plus 2AB cos theta. Here A and B is the magnitude of the vector. So here F is the magnitude, that is F square plus 2 F square cos theta, that is equal to the magnitude of result. That is also F. Okay. Square on both sides. Then what you get? F square is equal to F square plus 2 F square cos theta. Okay. Then here 2 F square plus 2 F square cos theta. This is equal to F square. This 2 F square come to this side. So F square minus 2 F square. So minus F square is equal to 2 F square cos theta. Okay. So this 2 F square take it to this side. That means minus F square divided by 2 F square is equal to cos theta. What is this? That is cos theta is equal to minus 1 by 2. If cos theta is equal to minus 1 by 2, theta is equal to 120 degree. Okay. This is about type 2. Now we will see type 3 problem. Type 3 problem. Two vectors magnitude A plus B and A minus B. Okay, and the resultant magnitude is A square plus B square. Then what is the angle between? What is the angle between these two vectors? Okay, so this is the question. So based on the vector algebra, we can write that the resultant magnitude is equal to square root of A plus B whole square plus A minus B whole square plus 2 into A plus B into A minus B cos theta. Okay, then what about the resultant? Here they are given us the resultant is square root of A square plus B square. So I am writing this. Okay, then squaring on both sides, then this square root and this square root is removed. So you will get here A square plus B square, and here we can expand this A plus B all square, that is A square plus B square plus 2AB you will get. Here we can expand by A minus B all square formula. So A square plus B square minus 2AB you will get. Okay, plus what about this? This is 2 into A square minus B square will get cos theta. Okay, clear? Then this A square and this A square you can cancel. This B square and this B square cancel. Remaining, this also we can cancel. This 2AB and this minus 2AB you can cancel. Remaining this A square you take it to this side and B square you take it to this side. So minus A square minus B square is equal to 2 into A square minus B square cos theta. Okay, then multiplying by negative on two sides. So here you will get A square plus B square. Okay, here you will get 2 into B square minus A square cos theta. Okay, then from this cos theta is equal to A square plus B square divided by 2 into B square minus A square. Okay, take the cos inverse and you will get 1. So theta is equal to cos inverse of A square plus B square divided by 2 into B square minus A square. Okay, this is the type 3 problem.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like